Okay, so question 3, part A. So I've been given some information. I've got A, I've got B, and I've got the intersection. And I want to find the union of A and B. I'm going to apply the addition law here. So I'm going to write it out, and then I'm going to sub in. And then I've got my answer. In part B, I want to find a conditional probability, the probability of not A given not B. Conditional probability laws, the intersection of the two sets, divide by the one that's already happened. Now this is quite an interesting idea, this numerator. Straight away have a think about the Venn diagram. I want not A, anything outside A, intersected with anything outside B. So I'm going to colour them in two different ways to identify the intersection quite easily. So anything outside B, I'm going vertically. So basically anything that they've both got the shadings. So I'm talking about this outside area. Mathematically speaking, the probability of not A intersected with not B, the numerator, is 1 minus the union of A and B. So I worked out the union already. So I've got 0.33. So that's the numerator of my conditional probability. So now putting it all together, probability of not A given that not B has already happened is the intersection over the probability of not B, which obviously is 1 minus the probability of B. The probability of B was 0.45. So I've got 0.33 over 0.55. In other words, 3/5. 0.6. Part C of the question. I'm given additional information. I'm given a new set, probability of C is 0.2, and A and C are mutually exclusive. Remember, that means there is no intersection, so straight away I'm writing that. There is no intersection. B and C are independent, so straight away I'm thinking law of independence, got it? Intersection is equal to the product of their individual probabilities. So I'm almost there. Part C. Part C says find probability of B intersection C. I know by independence that that's the product. So I've got the probability of B from earlier, 0.45, times the probability of C, 0.2. So I've got my answer there. And then I've got part D. Draw a Venn diagram to illustrate the events and the probabilities for each region. So let's see if I can look at that. So straight away, what do I know? I know that there's 3 sets, A, B and C. There's no intersection of A and C, but there is an intersection of A and B, and of B and C, because I'm not told any different to that. So A and C must not intersect, they aren't, but they are both intersected with B. What do I know about the areas? I know that the probability of A, that's equal to 0.35. Probability of C, that's equal to 0.2. Notice I'm putting them on the edges of the circles, not inside, because it's the whole circle that's 0.2, the whole circle that's 0.35. And the probability of B, that was 0.45. What else have I worked out? I've worked out the probability of A intersection B, that was 0.13, that's that area there. I've worked out the probability of B intersection C, that was 0.09. So I'll put that on as well, 0.09. And what else have I got? Well, I can work out these 3 bits, and I can work out the bit on the outside. So let's take one at a time. So to get this piece here, I've got 0.35 take away 0.13. That's 0.22. To get this piece here, I've got 0.2 for the whole circle. I've got the intersection being 0.09, so this piece here must be 0.11. And then this bit here, for B, I've got 0.45, but I've got to take off the 0.13 and the 0.09. So I've got 0.23. And then what I've left on the outside here is 0.22. How do I know that? Well, basically that is all those probabilities added to up, the union in other words, taken away from 1. And you should get 0.22. So, part E of the question. Part E of the question is finding the union of B and C not. In other words, 1 minus the probability of B union C. So if I can get the probability of B union C, then I can get the probability of B union C not. Probability of B union C, I can either use my Venn diagram or use my addition law. That's my addition law. I'm plugging in my numbers. I got 0.45 plus 0.2, take away 0.09, giving me 0.56. So the probability of B union C not is 1 minus 0.56, so 0.44.